Hello children, welcome to 7th Science online classes. Chapter 14 Electric Current and its Effects. In the last class, we studied one of the effects of electric current, that is heating effect of electric current and its applications. And today we are going to study magnetic effect of electric current. Effects of electric current. Two kinds of effects are there: heating effect of electric current and magnetic effect of electric current. Heating effect of electric current that we already discussed in the last class. That means electricity passed through a wire, that wire produce some heat. Okay, that is heating effect of electric current. And we studied some applications of heating effect also, like iron box, toaster, heater. These all are working on the principle of heating effect of electric current. And today we are going to discuss the other effect of electric current, that is magnetic effect of electric current. So that is very interesting. So let us see. Magnetic effect of electric current. First we will see the definition of magnetic effect of electric current. When an electric current is passed through a wire, it behaves like a magnet. See, that is a wire. Electric current passed through a wire or any conductor. Conductor means the material which allows electricity. So we can take one wire. So that wire allows electricity. So electricity passed through a wire that behaves like a magnet. So all of you know what is a magnet. So here in this picture you can see this is a magnet. Okay, and this magnet can attract any other magnet or some magnetic materials like iron. Okay, iron pin, iron, the objects made up of iron. So they are called magnetic materials. So a magnet can attract with other magnets and magnetic materials. And you studied that a magnet has two poles. Okay, like poles repel with each other and unlike poles attract with each other. That you studied in the last class. Okay, so anyway, and here this is called the magnetic effect of electric current. So what is magnetic effect of electric current? When an electric current passes through a wire, that wire behaves like a magnet. So that wire can attract some magnetic materials. And this effect was discovered by a scientist, Hans Christian Ørsted. So that scientist's name is Hans Christian Ørsted. He discovered that the needle of a compass deflects when an electric current is passed through a wire placed near the compass. And do you know what is a compass? So here this is the compass. I think all of you familiar with this compass. And this compass we are using to know the directions used in the navigations. Okay, so it can show the directions north, south, east and west, and inside there is one needle also, and that needle is a magnet. Okay, inside a needle is there and that needle is a magnet. Now we will discuss this activity. He discovered that the needle of a compass deflects. Deflects means it is moving. Deflect means a small movement. It deflects when an electric current is passed through a wire placed near the compass. So here in this picture you can see here one wire, and that wire is connected to the battery. So electricity passes through the wire. So when we keep this compass near to the wire, we can see some deflection or some movement of this needle, because the wire, electricity passes through the wire. So the wire act as a magnet, and this magnet attract to this magnet, attract or repel. Okay, So that is why this needle shows some deflection. This indicates that a magnetic field is created near the wire that deflects the needle. So we will just see this video also. Okay. See, so here one magnet. So that when we keep this magnet in here near to the compass, we can see the deflection of the this needle, because this is a magnet. This magnet attract or repel this needle, because this needle is also made up of magnet. And next, here one wire is there. Okay. Okay, you can see one more time. See that magnet. When you keep the magnet near to the compass, it shows the deflection. And now here one magnet is there. One magnet and one battery also. And we can use this thing to connect the battery very easily. See, these two wires. And the two ends of the wire, connected to this battery, and we kept this compass near to the wire, or on this wire, or near to the wire. Now you can see when connected to the battery, it shows the deflection. See, so now this wire acts as a magnet. So before we showed that when you keep the magnet near to the compass, it shows the deflection. The same way, the electricity passed wire, that also act as a magnet, and this compass needle deflects when it near to the wire. Okay, so that is called magnetic effect of electric current. And next is electromagnets. So the same way, so what is magnetic effect of electricity means? When electricity passes through a wire, the wire behaves like a magnet. So we can apply this thing in our daily life. Okay, we can use it. So that is called electromagnet. How we can make a magnet using this way? It is a magnet made by using electric current. An electromagnet works on the magnetic effect of current. An electromagnet consists of a coil of insulated wire wrapped around a piece of iron, which is magnetized only when an electric current is passed through the coil. Okay, so the same way, here you can see one iron nail, and we wounded or wrapped around one piece of wire, and that wire is insulated wire. Okay, that insulated wire wrapped on this iron nail and connected to this battery or cell. Okay, here only one, so we can tell it is cell, and we fix one switch also. Now when we switch on, electricity passed through the circuit. Okay, this is a simple circuit, so electricity passed through it, so this iron nail act as a magnet. That is magnetic effect of electricity. When electricity passed through this wire, this iron act as a magnet, and that is called electromagnet. So this can attract these paper clips, because paper clips are made up of iron or steel. They are the magnetic materials. So the iron can attract this paper clip, because iron now it is a electromagnet. Got it, children? Now I am reading once again. It is a magnet made by using electric current. An electromagnet works on the magnetic effect of current. An electromagnet consists of a coil of insulated wire. See, coil of insulated wire wrapped around a piece of iron. Here the piece of iron, here iron nail. Piece of iron which is magnetized only when an electric current is passed through the coil. So that sentence very important. When we switch on, it can act as a magnet and it attracts the pins. And when we switch off, this magnetic power loses also. Got it? Okay. The electromagnets can, and then we'll see some uses also. So before that, we will see the video also. Now you can see when we switch on, see the electricity passes through it, and this iron nail attracts. See, now switch on, electricity pass. Now it is act as a magnet. Yes, one more time, listen all of you. Switch on, electricity passed through the circuit. Now it is an electromagnet. It attracts the pins. Got it? Okay, so now we will discuss some uses also. The electromagnets can be made very strong and can lift very heavy loads. Okay, electromagnet. So we can see this crane. Have you heard the crane? So the crane can lift the heavy loads. So that is that crane contain electromagnet. So the crane take the heavy things and after that switch off, so it can drop the heavy loads also. So electromagnet can be made very strong and can lift very heavy loads. The electromagnets are also used to separate magnetic material from the junk. See, some junkyards, some waste materials dump in some places, and there is some many iron pieces, scrap iron pieces are there. So that we can reuse. And some iron material or magnetic materials, papers, many wooden pieces, many things are in the junkyards. So using the electromagnet, we can separate only the magnetic material from the junk. So that is the another use of electromagnet. Then next one, doctors use tiny electromagnets to take out small pieces of magnetic material that have accidentally fallen in the eye. When the people are workers are doing some welding or some that kind of work, sometimes it may fall some metal pieces, iron pieces, small iron pieces into their eye. So doctors are using electromagnets to take that magnetic material from their eyes. Okay, so these are the some uses, only some uses, and some toys Toys are also using electromagnets, and many applications are there. Electromagnets have many applications in our daily life, and these are the some of uses. Okay, so what electromagnet means? Here one iron nail or iron piece is there, and one insulated wire wrapped around this iron piece, and electricity passes through it. Okay, so that iron piece acts as a magnet, and when we switch off, that power loses also. Got it? And next is the last topic, electric bell. Electric bell. An electric bell works on the magnetic effect of current. So this is the another application of magnetic effect of current. Electric bell. Electric bell also have one electromagnet. Okay, we will see. It has an electromagnet in it. It's very important. Okay, electric bell is very important. So electric bell works on the magnetic effect of current, and it has an electromagnet in it. Okay, so we will see first the picture. Here one iron this is the electromagnet. So one iron coil, iron piece is there, and insulator wire also there wrapped around this. So this act as a electromagnet. Okay, so this act as a electromagnet, and this electromagnet is connected to one battery through a switch. A switch is there and one battery. That battery is the source of electricity, and this electromagnet attached with one iron strip. Here one iron strip, and that is attached to a screw. Can you see one screw here? And iron strip also, and this end of the iron strip there is one hammer, and here one metal gong. This is called gong. Okay, now we will see. So it has an electromagnet in it. So this is the electromagnet. It has a coil of wire wound around a piece of iron. So this is the iron piece, and the iron insulator wire wrapped around it. The iron strip with the hammer is kept close to the electromagnet, and also there is a contact screw near the strip. Okay, so here one iron strip, this is the iron strip, and that is connected to one hammer and one screw also here. When iron strip is in contact with the screw, the current flows through the coil. So that time when we switch on, the current pass through the circuit like this. Okay, that time this acts as a magnet, electromagnet, and this attract this iron piece to here. Okay, to here. So when it attracts here means that time it will hit on this gong, and we can hear the sound. When iron strip is in contact with the screw, the current flows through the coil and act as electromagnet. Then it pulled the strip and hammer at the end of the strip strikes the gong of the bell and produces sound. So that time when we switch on, that time it strike one time, then switch off, then switch on, off, on, off. That time it strike on the gong, and we can hear the sound. Okay children, so that is the electric bell. So electric bell also working on the principle of magnetic effect of electric current, and it has electromagnet in it. Okay, so it is very easy thing. Only what is magnetic effect of electricity? Electricity passed through a wire. That wire acts as a magnet. That is the basic thing. So keep that in your mind, and read everything in your textbook. It will be easy. So that is magnetic effect of electric current. And heating effect means when electricity passes through a wire, that wire produce heat. That is heating effect of electricity. So two effects we studied, and many effects are there that you will study in the next classes. Okay, children. So we finished this chapter also, and next class we will discuss the exercise part. So now all of you read your textbook and watch this video 2-3 times. Then complete your notebook also. Okay, I'll give some question and answer that also write in your notebook. Okay, so all the best. Thank you.